Hello everyone, welcome back to my YouTube channel. So this is a video lecture on series on basic electronics. It is 18 ELN 14/24. So we are discussing module number 4, feedback amplifiers. This is a lecture number 3. In this lecture number 3, we'll be discussing about types of feedback network, voltage series feedback, and gain stability with feedback as per the syllabus mentioned by our VTU. So let us see the details. It will go into details of the lecture number 3. The first topic is types of feedback networks. Okay, so depending on the type of feedback that is being connected back to the input side, we have total 4 types of feedback networks. Okay, the first one we say is voltage series feedback. Okay, voltage feedback is given in series with the input voltage, then current series feedback, then voltage shunt feedback, and current shunt feedback. Okay, so these are the mainly 4 types of feedback network that is available. So let us see those with the help of a diagram. Okay, so okay, let us see over here. This is the figure 1 that are showing on the that is seeing on the screen is the voltage series feedback. Now this is the operational amplifier op-amp 741 IC. We are giving the input Vin, fine, and we are getting the output, and this output is taken out parallelly. Just see here, one line is here, another line is here. This line is taken over, meaning is this line and this line are not touching each other. So this upper line is going over here, passing here like this. Now, so we are taking a part of output and we are giving this part of output to the feedback network. Now we are getting the output from the feedback network. We call that as VF, and that VF is given in series. That is given in series with the input voltage. That is what is called as voltage series feedback. Fine. Next is let us see the voltage shunt feedback. Voltage shunt means it is parallel, connected in parallel. Fine. Now just see here, this is the input voltage, this is the op amp. So we are taking out part of output, giving it to feedback network, and output of feedback network is given parallelly to the input side. Just see the difference over here. In this voltage series feedback, feedback is given in series with the input voltage, whereas in voltage shunt feedback, feedback voltage is given in parallel with the input voltage. That is what is called as voltage shunt feedback. Voltage series and voltage shunt. These are 2 types. Another 2 types is current series and current shunt. So in this current series, we are taking part of output, and that part of output is given in series with the input voltage. That is what is called as current series feedback. Whereas current shunt feedback, what we are doing is part of output we are taking, there's no doubt in that, but input is given in parallel. Just see this connection over here. Input is given in parallel with the input voltage. That is what is called as current parallel feedback or current shunt feedback. Okay, so this makes the 4 types of feedback networks. For your syllabus, only listing of feedback networks is there. That is, there are 4 series feedback network: voltage series, current series, voltage shunt, and current shunt. So these are the types of feedback networks. Okay, for you only overview, generalized overview is there for your syllabus. Fine. So let us go into the detail of one of the topic to be mentioned to be discussed as per your syllabus. Just see your syllabus over here. See, so types of feedback network is there, and after types of feedback network we have voltage series feedback. That is one of the type of feedback network we have over here. Voltage series feedback network we have. Now only one type is there for your syllabus, so that you have to discuss in detail. Fine. Okay, so this is the figure showing the voltage series feedback. Part of output is given to feedback network, and output of feedback network VF is given in series with the input voltage. So that is what is called as voltage series feedback network. Okay, let us go into details of this. Here the output voltage is sampled by connecting a feedback network in shunt or parallel across the output, and the output of feedback network is mixed in series with the input voltage. What is trying to say is feedback network is connected in parallel with this, and output voltage feedback network is given to the input voltage in a series. It is mixed in series with the input voltage. Thus, voltage series feedback is also known as series parallel feedback. Sometimes it is also called as series parallel feedback also. Now, by looking into the figure, this figure above here, so we can write it as VI. Okay, this is our V in, this is our VI, this is our VF, this is our V naught. So VI is the input voltage at the input point of this amplifier is given by V in minus beta V naught. This is V in and beta V naught is this voltage. So V in minus beta V naught we are giving. Okay, Vi is equal to V in minus beta V naught. Fine. Now let us write the expression for V naught also. Voltage gain of an amplifier is A, input voltage is Vi, then output voltage is equal to A into Vi. That is voltage gain of this amplifier multiplied by the input voltage. So that is V naught is equal to A into Vi, right? And what is Vi? From this above equation, what we have is V in minus beta V naught. So what we'll do is we substitute this over here. A into bracket Vi, in place of Vi we have V in minus beta V naught. If we multiply A with that, A into V in minus A into beta V naught. Fine. Now, so in this part of expression we have V naught. Here also we have V naught. So this is negative sign. With the negative sign, if you send it this side, it will be positive sign. So we'll be having over here, just I'll annotate it and show you. So what we have here is V naught is equal to, after you send this part over here, so I'll be having plus over here A beta. Okay, I'll take it as B only. A beta V naught. A beta V naught. Fine, which is equal to A V in. Fine. Now from this expression, if we take V naught out, so in the bracket we'll be having 1 plus A beta. So you'll be having, okay, which is equal to A multiplied by V in. Fine. Now if you send this V in over here, it will become V naught divided by V in, okay, is equal to, what we'll be having on the other side is A divided by 1 plus A beta will be having. So that is what is being written over here. V naught by V in is equal to AF, that is voltage gain, is equal to A divided by 1 plus A beta. Now what is this is called as, okay. Now what this expression V naught by Vi is equal to A divided by A1 plus A beta signifies that the gain of the amplifier reduces by a factor of 1 plus A beta. What is A? It is the gain of the amplifier. Okay, V naught by V in is gain. V naught by V in is equal to A divided by 1 plus A beta. Whatever A factor is there, it is divided by 1 plus A beta. Then what is the meaning of that is, this reduces the gain of the voltage amplifier by a factor of 1 plus A beta. This is all about voltage series feedback. Okay, I'll repeat. So what we have to do is, we have to take one amplifier, connect a feedback network, take a part of output, and output of feedback network is given in series with that. Fine. So write the expression for Vi, write the expression for V naught. In that, put expression for Vi. Okay, and simplify it and obtain the expression for V naught by V in, which is equal to AF is equal to A divided by 1 plus A beta. And what this says is, gain of the amplifier is reduced by a factor of 1 plus beta. A is the gain of the amplifier. Now, if the A is divided by 1 plus A beta we have, meaning is the gain, overall gain will be reduced by a amount of 1 divided by A beta. That is what he is trying to say. So this is all about voltage series feedback. Now, last topic what we have is gain stability with feedback. Okay, so how the gain is stable? gain stability with feedback we'll be discussing. Fine. Now, so what expression we have from the last previous discussion, that is AF is equal to 1 A divided by 1 plus A beta. Fine. Now, let us differentiate this equation both sides. Let us differentiate this above equation both sides. We have D by DAF of AF is equal to 1 divided by A beta. It's a constant term, so take it out. So differentiate A with respect to A. Fine. Now, since A into beta is too much greater than 1, beta is the current factor of the amplifier, it will be around 100. So 100 and gain. So let us say gain is 1. For example, 100 into 1 is 100. Number 100 is too much greater than 1. So what I can write, 101 can be written as 100, right? So what he's trying to say is, since A into beta is too much greater than 1, so what I can write is 1 plus A into beta can be written as only A beta, and differentiation of A with respect to A. Now what this equation says, that the above equation shows that relative change in gain, that is GA by A, in the basic amplifier gain is reduced by a factor of A beta. Okay, whatever relative change in gain, amplifier gain what we have is, it is reduced by a factor of A beta, because we have 1 divided by A beta multiplication factor over here. So that is what is reduced by a factor of A beta in relation with this DAF by AF. Okay, so in the overall gain of the amplifier. Okay, this is all about gain stability with feedback. Okay, with this we'll complete this topic to be discussed, that is the feedback amplifiers. I said that in this module there are three subtopics. One is BJT, another is feedback amplifier, next one is oscillator. So with this lecture we'll be completing feedback amplifier. If you have any doubts, comment me back, I shall reply you. Okay, thank you.